We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Good morning, friends. This is another lecture in the subject of experimental technique and instrumentation in thermal engineering. Myself, PATEL JIGNESH, Assistant Professor in MAHATMA Institute of Technical Education and Research Center, NAVSARI. This is one of the module of this subject, Advanced Measurement Technique and Analysis. Now, in this chapter, we have to talk about the gas chromatography, how it can be, we can taking the one fluid in which some volatile particle will be there. So how much amount of this volatility in this whole fluid, how much volatile particle will be there. So percentage of this volatile particle we have to measure by means of gas chromatography. Now we can see that how much volatile compound in this sample we have to find out by this gas chromatography method. Now first of all you have to understand that it has some phases will be there, mobile phase, stationary phase and we can see some of the component over there, molecular sleeve, column. So how it can be work actually gas chromatography we can see over there. So we can find out how much volatile compound will be in our sample. Now mobile phase is these are some component over there where column will be there in the form of it's a one kind of column or either in the form of coil. We see over there either in the form of column or either in the form of just coil. Now in the stationary phase we can see that this is the column and it can be in this column it has some wipeout at the screen of the column in which in the inside way silicon grease or wax will be provided. So what will happen actually, this silicon and stationary phase silicon grease or wax which is the working as just like a insulation. Also mobile phase which is the just a contain of the helium or nitrogen gas which can be provided some movement. So we can your sample can be moved from one place to the another place where we can see that molecular sieve will be provided. So your sample which can be just flow from the one place, like whenever we have to input a sample, so we can this sample can be flow from whenever input will be provided of the sample to this stationary phase. Now we can understand that first one how it can be work. So what will happen actually, this one is the first helium or nitrogen gas will be mobile phase will be provided over there. So this by using of this helium and nitrogen gas which is the inert gas, so it has no impact on any kind of process, so it can't be react with the process only. After that this molecular sleeve it can be passing to the column where it contained with the samples. So whatever we have to sample will be collected from this one, it can be passing to the stationary phase where we can see that in the inside of the stationary grease, wax or any insulation will be provided. After that it can be passing to the detector. Now you must be know about in the stationary phase how it can be work. In the mobile phase we can see that why we are saying that it's a mobile phase, because of this helium and nitrogen which is the help to sample to the move from one place. It means that whenever we have to inlet at the sample from that point to this stationary phase, it can be moved by means of this helium and nitrogen. So that's why mobility will be provided by these two gases, so it's called mobile phase. Now it can be passing to the stationary phase where we can see that this stationary phase how it can be work. Now this one is the actual idea you have to getting from this diagram how gas chromatography can be work. Now we see that this one is my mobile phase. Now this one helium and nitrogen can be passing through the molecular sieve, and then after it can be where we have to we have to adding the sample over there. We have to inject the sample over there. So what will happen actually at that point where we have to adding the sample, in the first phase your temperature of the injection region is kept 20 to 50 degree higher than the column. So what will happen when we are injecting the higher than 20 to 50 degree, what will happen, it will be, if we are supplying in the liquid manner, so it can be kept in a completely vaporized over there. So what will happen after that, this can be volatile content which will be passing through this column. Now if we have a 150 to 300 degrees Celsius in this chamber, so ultimately how chamber can be works, this is the coil form, but we already seen that in the just like the column where we are seeing that this one is a wax and grease. So similar thing will be happen in this coil also. So how it can be work actually, you can go further so you can getting the actual idea. After that it can be passing through this detector and you are getting the results. So what will happen in this chamber at high, we can find out in another figure. So this one, now this one is not in just like a coil, but we are just getting the as just column. So what will happen whenever sample can be added over there, now your temperature will be higher. So what will happen, whatever amount will be it can be volatile form, so it can be converted into gaseous form. So where density will be low, so it can be which has a density low, which has a travel will be higher compared to which has a higher density, which has a no that much velocity, so it can be travel lower to compared to this one. So this one is the volatility. As per this volatility, we can, as per density, it can be travel in this column. So particularly what will happen, we are separating over there by means of this density difference. So ultimately at the end of this tube, or we can say that in that again we can see the figure over there. So at the end of this one is my column end, so we are getting the volatile compound over there. So after that at the end of, we have to separate out the compound. So ultimately this detector can be what detector can be done. So we can see the another figure where you are getting the actual idea. At the end of this chamber or coil, we can see that it can be connected with the hydrogen cylinder or oxygen cylinder, where this volatile compound can be combined with the hydrogen and oxygen, where hydrogen and oxygen will be absorbed. Now it can be continuously flame out over there. So what will happen, it can be ionized either by means of this electrode, it can be ionized, and this detector can be detect over there how much amount of the volatile compounds over there. So particularly this one is the current versus the time graph where we are getting the compound. So we can see the another graph. So it can be, usually you have to know what is the detector, how it can be work over there. So we can see that when the separate out from the this volatility, we can see that where which are not that much volatile, so it can be stay over there. But which are the particles which has a higher volatility, it can be travel more than fast than compared to the other one. So now we can, when we are taking the standard reading, at that time we are getting the value of methane, which is after 5 minutes. Where acetone can be getting after 3 minutes only. So what will happen when we are getting the some value analyze unknown? So what will happen, we are getting the value of 3 minutes where we are performing this detector. where 3 minute, at that 3 minute we are not getting the value of acetone, not a single signal pickup we have to see over there. So we can say that by this of the image we can analyze that it has a no acetone, it has a no acetone, but it has a, after 5 minutes we have to pick up the some signal over there by using of this detector. So we can say that it has a some value of methane, and after that it's a 6 minutes. So for that standardization we can analyze the how much volatile compound exists in a sample we have to find out. So this one is the gas chromatography. Thank you for watching.